This is the summary notes for Chapter 6 on nomenclature, Part 1. This video is covering naming and writing molecular compounds. We'll first take a look at the properties and characteristics of molecular compounds, and then take a look at the prefixes that are used and practice naming and writing formulas. All right, so if we take a look at your screen, molecular compounds come from the above the staircase area on the periodic table. So it would be good to have a periodic table with you. You can look at your PDF handout that goes with these videos, and let's see what else happens. All right, electrons are shared to form noble gas configurations when molecules form. We can take a look at the Lewis structures. A couple of them are down here, and we'll be doing more of this in another video that goes with this chapter in Part 2. Remember, prefixes tell us how many of each atom are in a formula, and this is very important for molecular compounds because you sometimes have many versions of two elements getting together depending on the prefixes. And those prefixes will tell you what the name is. It also gives rise to different chemical and physical properties for those substances. All right, in general, molecular compounds are soft or they could be brittle. And sometimes they're in the gaseous states. They tend to have low melting points, and again, we'll see that in one of the videos on intermolecular forces. Carbon in diamond is an exception. It is a solid at room temperature. Okay, the prefixes are here, and again, this is in your reference handout, so be sure to have that handy. All right, and then just to review some common molecular compounds here. I'll highlight a few. We just looked at carbon dioxide, where the prefix Di was being used to mean two oxygens. And here again in carbon disulfide, the same thing. Hexafluoride down here, a little bit further down the chart, hexa. And then there's another di in front of the oxygen and a tri in front of sulfur trioxide. Sulfur trioxide kind of looks like SO3 2 negative. But it is not that is the polyatomic ion, or SO3 2 negative, is not the same as SO3. All right, so please make sure this is the ion and this is the molecular compound. So you might see several of these that look like, and I'm just going to abbreviate compound there for you. So sulfur, sulfur trioxide is not the same as the sulfate ion. So be careful with that, please. All right, so let's take a look at naming this particular example that's here, this B2O3. All right, so B2 is going to be represented as diboron, B-O-R-O-N, and then trioxide. Okay. The next one is nitrogen trichloride. All right, and it's at this point where I should say something about the prefix mono. Mono is not ever used for the first element. All right, not used for the first element. All right, it's not used for the first element in the name. It is occasionally used for the second name, but in some examples that you see here, nitrogen oxide, dinitrogen oxide, you notice that the mono is not there. The most popular or the most known mono version of a molecular compound is carbon monoxide, and most of the other names, it has been dropped. All right, so diphosphorus pentaoxide. All right, so that will be P2O5. All right, notice here in the penta, the A was dropped. All right, the A gets dropped from that prefix. All right, so take a moment, stop the video, and see if you can answer these, selecting the correct name in this next set. All right, and then come back and check your answers. All right, so SiCl4 is silicon tetrachloride. So you see that down here as a letter C, silicon tetrachloride. P2O5 Did you get diphosphorus pentoxide? And Cl2O7 is dichlorine heptoxide. And again, notice on the prefixes that the A got dropped in the hept and the pent. Okay? It's just an easier way to pronounce it with that A not being there. All right, so this last one, I ask you to do a little bit more. All right, look at your compounds that are here, decide whether they're ionic or covalent, and then give the correct name. All right, so again, pause the video and come back and check your answers on these. All right, let's check your answers on this set. There were only 2 covalent compounds, molecular compounds in your list, the first one and the last one. All right, and they're written in that gold color. All right, SO3 is sulfur trioxide, and again, they're only nonmetals, which makes them molecular. Barium chloride is a metal plus a nonmetal. All right, it doesn't require a Roman numeral because barium is a group 2A metal. All right, ammonium phosphite. It's named ionically because the polyatomic ions are positive and negative, respectively. All right, copper 1 carbonate. I hope you remembered your Roman numeral on that one. Copper is in the transition area, so it requires that Roman numeral. All right, not all do, but most of them do require Roman numerals for their variable charges. And lastly, you have a covalent molecular compound, dinitrogen tetroxide. And again, that A is dropped between the tetra and the oxide part of the name. All right, I hope you did well on these, and that ends this part 1 set of videos. And I apologize if you can hear my beagle barking. He barks at everything.